Hey y'all, today I'll be going over Leetcode problem number 20, valid parentheses. So given a string S containing just the characters parentheses, curly braces, or brackets, determine if the input string is valid. It's valid, all open brackets have to be closed by the same type of brackets, and they have to be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. So what that means basically is like, think of it like code, right? Look at this code right here. These are actually valid because see, this curly brace is closed by this curly brace. This curly brace is closed by this curly brace. And this parentheses is closed by this parentheses. So that's kind of like the use case for it. And like in math too, right? Kind of the same thought. So this is valid because this string number 2, example number 2, is valid because the parentheses closed by the parentheses, brackets closed by the bracket, and then this is. This string is, so this is good. This is not good because look, this one would be closed by one that's not of the same type. Something like this would be good, but if you take those away, that's also not good because they're never closed. That's another case. That's an edge case, right? They have to be closed, and they have to be closed by one of the same type. So first of all, for this, this is perfect. We will be using a stack of characters, and I will call this a stack, new stack, like that. And the reason why we want to use the stack is because we can put the opening characters in, and whenever we encounter a closing character, we could just check the last one that's in the stack, and the closing character better match the one that's at the top of the stack. So now another thing that I like to do is we can actually map characters to characters, and we can have this be the matches so that we already know how to map the closing with the opening. So this one's a closing here, and this will be mapped to the, and this map of is just a way to initialize a hash map in one statement. So something like that. And we'll do this a few more lines, but with different things. So this one here will map, we want to map the closing to the opening because we're going to store the opening in the stack. And then when we encounter a closing, we want to check if it matches, right? Let's do the brackets as well. And let's do the curly braces. So like that. Okay, so we have our matches. Next thing we have to do is we have to go through the string. So for car C of S to car array, so we have our characters. First, we check if it's an opening one or a closing one, right? So if matches contains key, because over here, these are like the, when we do this map of, this is key, value, key, value, key, value. So if it contains the key of C, that means this is a closing. And if we look over here, it has to be closed by the same type of brackets, and they have to be closed in the correct order. We're going to take care of those two things. This is a closing character. We need to check that the opening, the corresponding opening, matched. So then we'll check our stack, right? So if stack is not empty, or actually we can go if stack is empty, because we can do like a early break here. If it's either empty, because if it's empty, then that would be the case like we're given like this, right? Just a bunch of closings. We'll encounter a closing that has no opening because the stack will be empty. There'll be no openings there. And then we should just early break and return false. It's not valid. But if it's not empty, we also have to check that the stack dot pop is equal to the corresponding matching opening of this current character. So matches dot get C, right? And not equals, not equals. We go like that, not equals. So that, and then we just early break and return false. And then the else over here, well, we'll take care of that. But first I have to explain what I just did. So basically here we'll pop the stack and we'll have to make sure that the corresponding opening is actually equal to the current character that we're on, because, or the corresponding, yeah, you get what I'm saying. The match of the current character is equal to the one that's in the stack. So then we return the false, and we do pop, not peek, because we also want to pop it from the stack. Because even if it equals, and this is good, we're still gonna pop. So that's a good thing, actually. And the else over here, that means it's an opening. So we just simply add this character to the stack. And very lastly, we will check one thing. All characters have to be accounted for. So we just have to return that stack is empty. Because if it's not empty at this point, it's also false. So we run that. Looks like it passes all cases, and we submit that. Let's go over time and space. Looks like it's good over here. It's decent in time. So the time is going to be O of n, because we're just going character by character. And looking up in this little map is O of 1, and also it's a very small map. And then just popping from a stack and adding to a stack is O of 1. So ultimately we're bounded by the time taken to go through each character, which is n characters time O of n. Space will also be O of n, because worst case we have to store every single opening character in the stack, right? So that's time and space, and I hope this made sense. But to reiterate, because I might have flown through this and this might be confusing to some people, to reiterate, we go through each character. If it's an opening character, if it's a closing character, we first check, is the stack empty? If it is, that's bad, because that means there was no corresponding opening. Otherwise, we pop from the stack and we make sure that the character in the stack is the matching opening character that we expect. And we get that from our matches map. If not, we return false. Otherwise, that means it's an opening character and we add it to the stack. So, yep, hope this made sense. Thank you for watching.